Hello, welcome to the first e-learning class from the JIC platform. This is Dr. Muhammad Imran. Today, we are gonna cover some of the topics from your pacing schedule week number 9. Those topics are acid-base and neutralization reactions. It's in your textbook page number 170 to 175. Oxidation reduction reactions, page number 176 to 180. And the concentration of solutions on the page number 184 to 186. So let's begin. In the daily life, we may use some of the acids per day almost. One of the most common example of the acid we use to drink is acetic acid. There's another acid which we normally drink is in the lemon. Which is good for health actually. It's a vitamin C, ascorbic acid. It's also in the lemon. But the noticing thing is that all of them are sour. Most of the fruits we eat which are sour actually containing acids in it because acids are sour in taste. Whereas the bases normally which we use for the household purposes is normally for cleaning. The one you see on your right hand side is ammonia, which is used for the cleaning purpose. Well, some of the green vegetables which are having bitter in taste, they are actually basic in nature. And that is why your doctor often asks you to eat more vegetables rather than taking Coca-Cola, Pepsi, or taking fast food. Because fast food and Coca-Cola, Pepsi have lots of acid in it. To neutralize that, we need some basic vegetables. Let's begin. Now, let us first define what is acid. According to Arrhenius, he was a scientist, and another two scientists, Bronsted and Lowry, they gave a concept of acids. They said acids are those substances when you dissolve them in water or they gives out H plus ions in the water. You know, aqueous solution means solution in water. The term aqua is taken from water. So all those substances, when you dissolve them in water, they ionize, they produce positive and negative charges, and one of them is H plus ions. The H plus ion is also called proton. You know that in the whole periodic table, there are only one element which does not have a neutron normally. That is hydrogen. And when hydrogen loses electron, the only thing remaining inside the hydrogen is proton, and that's why we call it as a proton. And therefore, sometimes the acid is defined as all those substances which are proton donors. Here is one acid, sulfuric acid. It's a proton donor. When you put it in water and dissolve it, it breaks up into its charges. One is H plus, which is a proton, and the other negative charge part substance. There are many acids: hydrochloric acid, sulfuric acid, nitric acid, and so on. Now, there are different acids also based on how many protons they can provide in the water. The acids which gives out only one proton, they are called monoprotic acid. Mono is a term used for one. Protic means proton, and acids means those substances who gives proton are called monoprotic acid. The example for them is hydrochloric acid HCl or acetic acid CH3COOH. When you dissolve them in water, they dissociate into its charges, forming H plus ion and the negative part of the acid. In this case, it's chloride ion. In the other case is acetate ion. Now the acids which gives two proton are called diprotic acid. When you dissolve those acids in the water, which can provide two protons, is the example of diprotic acid. You might also know there is another triprotic acid which is H3PO4. It's a triprotic acid because it gives three protons when you dissolve it in water. I'm carrying on with it. Whereas basis is defined by Bronsted and Lowry in a way that anything that except H plus they are called bases. Well, compounds do not contain OH can also be bases according to the Bronsted and Lowry concept. Whereas Arrhenius said for the bases that bases are those substances upon solvation in the water they gives out OH minus ion, hydroxide ion. But later on, Bronsted and Lowry, they were brother and sister scientists, they said, well, bases can also be those substances who can accept H plus rather than giving OH minus ion. Some substances rather they accept H plus and they are also as a base. The example they have been given over here is ammonia. We all know that ammonia is a gas, and by looking of the molecule, it does not show any OH ion there. So when you dissolve ammonia in water, actually it takes the hydrogen from the water and becomes ammonium ion. That is why ammonia is termed as base because it accepts the H plus. Here in the photo, it shows a litmus paper and shows that when a blue litmus paper you dip it into an acidic solution, it becomes red in color. Whereas a red litmus paper, when dipped inside a base, turns to blue. Now we are going to talk about strong acids and weak acids, strong bases and weak bases.